Okay, I have a slight update. It's not going to be as big as my last one, clearly, because the last one was the first video vote loaded, but I did make some changes. As you can see right here, the character model looks a little different. Well, you may not know this, but as you side by side, the character model should look a lot better, and I'll go into why that's the case once I get to the new thing that's been implemented, and it is coming up. All right. All right. Here it is. Look at this. So we have a new floating platform, and look at the collision. Looks kind of bad, but yes, he's able to jump on this platform, and this took a really long time to get correctly. Um, yeah, I know it looks easy, but it was not, and I will go over to all the effort it took to make this work because this looks like a this looks like a really easy feature, but it was not. And the collisions are still a little bad sometimes. Look at well, there's some cases where there's some clipping. Well, I can't recreate it, but it's yeah. Look at that, yeah, stuff like that. That is bad, but it's fine. We'll figure that out. Okay. Um. So this is a concept known as simple harmonic motion. So, simple harmonic motion. This was a new concept I had to learn. Um, I kind of asked for the mathematics here. So, if I can remember correctly, without having to look, it uses oscillation, um, and it uses periods. So, like a period of time, a discrete period of time, and what happens is your it is meant to oscillate between two different periods, and it's really the gist of it. It's the simple harmonic motion. I looked at this website to kind of figure everything out. This is a really good website for that discussed it, um, and we are talking about things like frequency. So as the platforms going up and down, we are discussing the concept of frequency. Um, and as you can see here, is 1 over t, t being elapsed time, and that is the basis of this function. And if we get to simple harmonic motion, um, hold on, it is omega, I think. So yeah, it's omega. So that's 1 dot. So 1 over the period of time, which is 1 over t, uh, times pi, and that will get you omega, and then we have this delta, and the delta is the elapsed time, right? So start time, elapsed time, and then we have amplitude, and amplitude is what will get you like as you want to go, how high you want to go up, how low you want to go down, right? So it's the meta amplitude. So it's a difference between the discrete states, and it's the main function here. So what I do is isolate it on the y position most of the time, and because I'm going up and down. But if I wanted to go left and right, then it would need to oscillate the x position. So that is the case here, and um, and of course this is talking about frequency. So yeah, so that's the case there. But the problem is with collisions is that we have to resolve a jumping state, and we have to make assumptions about the character's ground state. So when we do that, what happens is that the character is constantly going back into a jumping state. So as you keep going down the elevator, he actually will just reset his ground state because his ground state is changing constantly. So there's a little trick here, and this is so esoteric. I couldn't Google questions anywhere. I asked AI so I asked AI about this issue. and it recommended this, and I'm like, okay, well, how did you find that? Because I was searching Google everywhere, and I could not find any information about this little trick. AI told me it could be lying, but it told me that due to most people using a game engine for the most part, like for this, especially to make these platformers, this knowledge is fairly esoteric. It's kind of tribal knowledge amongst game developers. So you would almost need to find this like on a forum somewhere. So I would say I still stand by the fact that I don't like AI to generate code for me, but in terms of learning concepts, in terms of learning as a result aggregator and a research tool, it's, oh my gosh, it's phenomenal, right? I can't yeah, people say that you shouldn't learn with AI. I just don't think they're dealing with problems that are esoteric enough to require it. Because yeah, if I'm trying to figure out how to do a web server, I can Google search that for the most part. But if I need to figure out nonsense like this, I would never build the intuition to do this. This is ridiculous, right? So the first thing is you have the platform, and then you check the collisions, and then we need to resolve the collision. So remember, when you do collisions, you also need to resolve the collision, right? So this trick right here will elevate the character slightly above the platform, right? So that he's kind of put into a state where he doesn't fall through the platform, because that's a problem. As a state change, you can actually fall through the platform. I ran into that a lot. And then, um, and also, because you are checking the ground every single step you take, that's how the collisions work, to make sure that you don't fall to the ground. You constantly are checking against the ground state. You have to actually check the feet. So this equation right here, this this physics body, this is actually how you check the feet, right? So let's think about, you have a square, and you were taking the length of it divided by 2, and you're adding it to the x position, which discovers the position on the triangle with the rectangle. Then you add it to the width divided by 2, right? So that that is what gets you the lower part of the character's body, basically. So yeah, yeah, it is quite annoying to deal with. Secondly, um, because you have to elevate this slightly, this means that the character's in a jumping state every single frame you move forward. And this is a helper function I have to get the colliding tile. And so you, so here's the trick. You actually have to extend the character's hitbox. So I need to take a copy of the character's body, reduce it by about 4 pixels, and then pass the temp copy into our collision system, which I built, and then we resolve it. So so this is just the equation to resolve it on the x-axis. Now the y-axis gets tricky because we have a vertical moving platform, right? Or horizontal, yeah, vertical moving platform, and going up and down means that you reset him into a he gets reset into a air state when he's not supposed to be reset into an air state. So the same trick applies, right? I have to take a temp copy. So I iterate through my platforms. I take a temp copy of the body on the x-axis. So anytime he's on the platform, I check the collision, and then I extend his height, so that he's always seen to be in a grounded state. And I will demonstrate that again, because I know it doesn't make any sense, and you won't notice until you run into this problem. I will say one thing: most people, I found this out after I started doing this. Most people do not write their own physics engine like I'm doing. I recommend that you don't, because there is a library called Box2D, which is already difficult to use, and I'll just make it even more difficult by doing what I'm doing. So it's a good learning experience. I am. It does help me out with, and this is a learning thing. So it does help me out with spatial reasoning, which is something I'm kind of weak at. But spatial reasoning is a big part of game development. As you were able to nail spatial reasoning, you can probably deal with most problems in computer science. Um, yeah, as you can see, you had a really good. If you have a really good high resolution, you can actually kind of see he's elevating on top of the platform by a few pixels. You just don't notice it, right? But you can notice it. It's a little trick that hopefully the people just wouldn't notice playing. But you know, if you look hard enough, he is elevating above the platform a little bit, or he's going into the platform a little bit. Um, yeah, so that's that. I do have some really cool plans after this, so I'm going to have him go up a little bit more here. He's up to the top of the screen. I'm going to go up a little bit more, freeze him, and I'm going to actually start the boss battle. So, and that's when I will add the enemy. This game is a game. When I design it, it's going to be a game but nothing but boss battles. So, I want the boss battles to have this kind of more 2D but cinematic quality to it. And that's going to be hard because, yeah, it's going to be hard to do, but it's going to be fun. That's a game I want to make. So people say um, don't make hard games, but I feel like if I was trying to make another breakout clone, I probably would have quit this project like within a week. So, all right. Oh yeah, we need to actually talk about this because this is me constantly running into problems when it comes to the learning GPU programming. I am a GPU programming novice. I saw this code last time I gave an update. This coding doesn't need to be here, but we have a blend mode. So this is all GPU stuff. I want to say this. Um, let me do this. Well, no, I'm not going to do it. Actually, let me do this because it's easier just to demonstrate it. Let me see if I can take this character's. So what I'm going to actually show is while this character looks 2D, when it goes across the GPU see things in kind of a three dimension, they kind of see things in a three-dimensional plane. Let's see if I can actually make this character. I'm not sure if I can. Let's see. I'm not a graphics artist, but there are parts of this character's animations, and essentially, when you play an animation like shooting a gun, right? This character, or actually, is his run cycle, but if you look at his gun, his gunshot, as you can see, his wrist is flicking a lot, right? And this is what you call a mesh deformation. And if you do 3D graphics, what happens is that you have vertices, right? Because the GPU only understands triangles, so they only understand vertices. And when it is when it's resolving the math, right? It's taking a number of triangles and it's sort of like combining them. When you have these very dynamic animations, you are deforming the the character model, right? Even though it's a 2D character, you're able to kind of deform the lines in a way, and that is articulated. Its articulation is through vertices, right? So with that said, now the reason why I'm saying that because I actually want to make sure this makes a little sense to people because this code looks quite hard to understand. So remember, when you have an atlas, you are reattaching these different parts of the atlas. Let me show you the atlas because this gives you a little more context. Let's see, we got the PNG here, PMA. Here it is. I think it is. There we go. So this is actually what the image is. As you can see, this character is split apart into all these different parts right here, right? And that's the way how you're able to do rigging. It is connected by bones and it's connected by rigging. Okay. What actually ended up happening is this character has to be drawn. And so when I pass this to like through my program, like through my game, what I need to do is I need to pass the PMA, and that is the pre-alpha, like I think it's like pre-alpha, pre-multiply alpha, right? As to what that means, I'm not going to try to explain to you because I don't know that well. But and then you pass it to you pass these vertices, and then so when we do this, we go and we get the vertices, right? And then what we do after we get the vertices, the real vertices, then we iterate through each slot. And each slot is what attaches the bone. So you have attachments. You have so anything that assembles the body is considered a regional attachment. Okay, and it's very important. Um, so and also remember, as we have a sheet, it's a square, right? But since the GPU only understands triangles, then it goes into a draw mode called a quad. Okay, and when it becomes a quad, so let's see. As you see the draw mode, let's see. Oh yeah, here's the draw mode. So when we begin the draw call, right? So it shows us as a quad. The quad has about 8 corners, right? And these represent the 8 corners. So as you see, I'm going, and so I'm going through the textures, and then I am taking the offset, or I'm taking the index, and then I am taking these, and then I am locating the different parts of the quad that I want to use. I batch it for the GPU, and then I send it to the GPU to be drawn. And the same thing is happening here. Now this is the mesh attachment. And when I have the gunshots, when I have the run cycles, this is an example of a mesh attachment. Okay, many pro assets use this, right? So it's a mesh attachment. And because of this, this attachment mode has slightly steeper math because it's doing I think it's doing a lot of matrix multiplication, because I think when you have these vertices, they are represented as matrices. The vertex itself is a tensor, but I think when combined, they're really large matrices, and so these get scheduled on the GPU, right? And what we're doing here is we're taking the row vertices, we're indexing them, right? So we have a coordinator taking the row or all the vertices, we're passing them to the port of the GPU. I guess that handles the vertex maths, and then we are iterating, and then what we do is we batch it, and then I guess we have like a blend mode, right? And blend mode should make sense because a blend mode is what actually assembles and blends the colors together, and that's what creates the computer graphic. Again, I am a complete novice. I didn't expect me to be like a Jonathan Blow when it comes to explaining this stuff because I've just learned this in like 10 months. I'm not this is the only like sort of GPU specific stuff I have. Like Raylib abstracts away some of the GPU low level calls, but when I am combining this with spine, I'm only using a C library. There is no abstraction for me to use, so I have no choice but to make this call. And also, this is you want to interested in how you're able to kind of interact with C. We have a void pointer, and this void pointer goes to our texture, and our texture then gets fed into the GPU. So we are just taking the memory associated with our texture, and we are doing that. And also, I do this too. one day I need to go over the game architecture, um, but the Spine C library also has a callback mechanism, um, and I want to say SP. I can't remember where this is located. Let's see. Oops. Let's see. Load texture. But yeah, it's my asset manager. Yes, that's correct. It's been a while since I wrote this code. These are all callbacks. These are all C. These are all C functions, but they're exported into they're actually exported into Zig. So here's what this export means. And here I need to create a callback. So I need to override this with my own stuff. And then I need to use a C allocator to do this because Zig has its own allocators, but they also create backwards compatibility with C allocators. I don't want to get into it, but it's quite a thing. And so when I set the textures, I also set the filter mode. So that's also how I kind of fixed the jagginess because apparently there are. So this character initially is that I have here. This asset I have here is quite large for my screen. So to be able to get him to fit into the screen, I hate to shrink him down quite a bit. And when you shrink him down quite a bit, the amount of pixels get compressed, and that creates that creates jaggedness. So the character can look quite unrendered. So I believe bilinear mode does like a sort of a smoothing effect. I just kind of looked this up and I just kind of just said somebody told me this was the answer, so I just I just did this. I honestly don't know too much of the theory behind bilinear blending from first principles, so that's the thing. So next time I am going to implement my boss battle, and I'm going to play a cinematic sequence. And because it's going to be a cinematic sequence, I need to mess around with game states. So I had to do quite a bit of refactor before this video, but I actually need to do furthermore refactoring because right now there's only one game mode. I mean, besides the menu screen and besides the title screen, the menu screen, but the play mode, but the gameplay aspect of it, when you can control the character, I need to find ways to pause it and create a cutscene, and that requires me going to the global game state, and that's going to take quite a bit of refactoring. So that will be fun. But yeah, it's coming along. And then once I do that, I'll be able to work on combat finally. This is an action game, so it needs a little bit more action. But anyway, I just wanted to give this update. But I wasn't expecting to update this fast, but I expected the platform stuff to actually take quite a long time. But it did take it took a week, but and I guess a week is a long time in these days with AI, right? Yeah, but like I said, it's a learning for me. So if it takes me a week to learn something, I do. So that's a big thing. So yeah, I'm going to add game states cinematic mode where we're able to pause things, and then I'm going to add the enemy. Now, I hope this enemy is rendered correctly. I should be able to just swap in any asset now, and it just get loads. But when the GPU math is off, you get some horrifying graphical effects. I want to get into it, but it's definitely jump scare city. So but yeah, I am going to sign off and have a great one.